Welcome back to part 2 of finding unit rates with fractions. We are going to look at the bulk of this right now. So how do we find them? Let's go exploring. So what do we do when one or both quantities are fractions? So 3 friends are training for a 1-mile race. Their rates are shown in this table. How long will it take for Sasha to run 1 mile at her current rate? Use any method. However, be able to justify your method with how it works. Remember in the launch, we talked about the bar method and scaling, and if you find up another way, that's fine. So let's look. Let's explore. All right. So how could you use a bar diagram to find the solution? Draw a bar diagram that helps solve the problem. Be prepared to explain why your problem works. Go ahead and pause and do this on your own real quick. And then come back and we'll see how we should solve this. All right, hope you have your math done. Let's go look at how this is solved. All right, so here's an example. Sasha's rate is 1/4 mile in 65 seconds. So they broke our mile up. We have 4 pieces to a mile. We know that 1/4, there's 4 quarters, so we need 4 pieces. So each one of those pieces is 65 seconds long. So we're going to put those in. Uh-oh. Now I got to figure out what they are all together. So I'm going to take 65 plus 65. Oh no, there we go. So if we start with 65 for quarter 1, 65 for quarter 2, and 65 for quarter 3, 65 for the last quarter of the mile and add them all up, 5, 10, 15, 20. And then I carry my 2, 6, 12, 18, 24, 26. Should be 260 seconds, if I did my math right, that it takes her to run an entire mile. Let's see. Oh, that worked. Okay. 260 seconds, 65 seconds for each mile. I just plugged it in and did some basic addition. We got it right. Look at us go. So it's just breaking it down. If this said said fifths, I'd have 5 pieces to do it with. Bar graphs work to break it down into those pieces. Let's look at this. How could I use scaling? Well, scaling is when I multiply to get more numbers. Not more numbers. That didn't make sense. Scaling is when I find the unit and multiply that number by that. So try and figure this out. How could you use scaling to solve this problem? All right, ready? Let's go look. See if you got it. Ugh. Did it just totally skip? It did. Okay, scaling. We'll show you. All right, let me add some more space into this. Ooh, Lord. All right, scaling. So I know that I have 1/4 equals 65 seconds. How do I get that to be 1? Well, I have to multiply by the reciprocal, remember? If I multiply by the reciprocal, that becomes 1. What am I multiplying by? I am multiplying by 4. So if I'm multiplying by 4 to get to 1 mile, I have to multiply my time by 4. So if I do 65 times 4, 20, carry the 2. 6 times 4 is 24, plus 2 is 26. Hey, look, I got the same answer, 260 seconds. All right. So, where do you see that scale factor at? Where did I get that from? Well, it's from this denominator here. Our denominator in our fraction is my scale factor. It will always be your scale factor. Not always. If you have a fraction, it'll be your scale factor. Because you got to get that, there's that reciprocal, you got to get that to 1. All right, so I want you to think about this for a minute. How does solving the problem using a bar diagram relate to solving it using scaling? Which method do you prefer and why? Go ahead and write your answer down. Think about it. You can write that down. All right. So, if Pedro and Emily continue running at the same rate, how long will it take how long will it take each of them to run 1 mile? Use any method. I want you to solve these. How long will it take Pedro and how long will it take Emily? Come back once you've solved them. All right, ready to see if you got it right? Let's move on. So we're going to use bar diagrams to solve this. The bar diagrams can be used to find Pedro and Emily's unit rates in seconds per mile. So we're going to complete them. Pedro ran 2/3 of a mile in 240 seconds. All right. Let's give a little bit more room. Let's get that old stuff out. Oh, never mind. All right. So we have 240 seconds to 2/3 of a mile. Uh-oh. What do I do to get that fraction to 1? What do I have to do? Multiply by the reciprocal. So I'm going to multiply by 3/2. Whatever I do to the bottom, I have to multiply by the top. So let's see. So 240 over 1 times 3 over 1 times 3/2. I bet 240 has something it shares with 2. 2 is 1. 240 divided by 2 is 120. 120 times 3 is 360 over 1. I bet it will take 360 seconds for Pedro to run the entire race and 120 seconds for each third. So let's get that typed. So I said it's 120 and 120 and 120. All right, so now Emily is 275 seconds to 5/6. I gotta turn that 5/6 into a 1. How do I do that? I multiply by the reciprocal. Whatever I do to the bottom, I have to do to the top. So we know this becomes 1. So it's 275 over 1 times 6/5. I bet 5 goes in because that's a 5, and 5 usually goes into numbers with 5s. So, I got to do some division here. So 275 divided by 5. 5 goes into 27 5 times. That's 25. 2. Bring down the 5. 5 times goes into 25 5 times. That's 25. 0. Cool, I can reduce these by a factor of 5. 5 divided by 5 is 1. 275 divided by 5 is 55. Multiply straight across. 6 times 5 is 30. Carry my 3, 330 over 1. I bet it takes 330 seconds for Emily to run the full race and 55 seconds per 1/6 of a mile. Uh-oh, I gotta go fix it. There we go, it fixed it. It didn't. What's going on? Uh-oh, too many numbers. There we go. And the last one. There we go. Let's check our answer. We got it right. Remember, make that bottom part of your fraction V1, and whatever you do to the bottom, you have to do to the top. All right. How can you find the unit rate in which one or both quantities are fractions? Take a minute, think about it, write your answer down. Come back once you're done.